Great, yeah, and as Missy said, this project is part of a multi-year trial that we are trying to look at the effect of a biological on wheat yield and growth characteristics. This project was actually thought up by Dr. Paolo Pagliari. He's my counterpart down in Lamberton, so I'm at the Northwest Research and Outreach Center in Crookston, and he's at the Southwest Research and Outreach Center in Lamberton. And yeah, we are collaborating to have kind of a northern site and a southern site to hopefully get some, good climate responses between the two sites. But we're going to talk about how that went here in a bit. The rationale for this, and I know biologicals are a really hot topic right now when we're talking about nitrogen use, especially with the high cost of commercial nitrogen fertilizers. So the idea behind these is to improve the soil microbial community and stimulate it to fix atmospheric nitrogen and provide plants with nitrogen. It's kind of acting like your soybeans and their symbiotic relationship in those rhizomes to fix their own nitrogen. So this is kind of to attempt to simulate that by inoculating the seed with a bacteria. And the other idea behind it is that with a more robust microbial community, you can help the plant's ability to handle stress. So the objectives of this study were to look at whether inoculating wheat with this plant growth promoting bacteria does have a positive impact on spring wheat yield and growth characteristics. But then we also wanted to look at, what rate of inoculum we would apply, and then if there are any differences between the two locations in Minnesota, and also looking at, how much is that bacteria actually changing or not changing soil nitrogen concentrations in the area of the roots. So the methods, again, there's two field trials kind of stacked into one here. The first one, we are looking at 5 different rates of nitrogen, but varying, but keeping a constant inoculation rate. The 1.37 ounce per acre is the recommended rate of this inoculum. And the other one, we're looking at kind of different combinations of that rate with either not applying any nitrogen or applying a fixed nitrogen rate. And this is really by limiting the amount of nitrogen that the plant is receiving from commercial sources, we're really testing this microbe's ability to fix that nitrogen and supply what the plant needs. And again, 2 locations, north and south. I am not pointing in the right direction. Wait, it's early today, isn't it, right? Thanks. So yeah, we looked at this particular inoculum following 3 different crops. Wheat after soybeans was present in both locations. We did wheat after corn in Lamberton in 2021. But in Crookston, we actually didn't have any corn crop that we could put this trial after for 2021, so we tried wheat after sugar beets. But in 2022, we did have wheat following soybeans and wheat following corn in both locations. There, I think I got it that time. And what the wheat seed was inoculated with is Azospirillum braziliensis. You can read it. This particular microbe is from Brazil. So Paulo he had read an article from Brazil's version of USDA, and they were having really good results with this particular bacteria as an inoculum. So he contacted them and got approval to import this bacteria inoculum from that group in Brazil. So this is a non-native species to Minnesota, but kind of as a side note, one of the things we are thinking about if we see good results with this would be to see if there's a native Minnesota bacteria that can sort of provide the same function. We're working with another soil scientist in our department, Dr. Satoshi Ishii, and he is helping us isolate different types of bacteria native to Minnesota that so that we wouldn't necessarily have to import a bacteria from Brazil to do this. And then also with those, so the wheat seed was inoculated at the time of planting. We basically just spread the inoculum on the wheat seed right before we put it out and planted. So then that's another part of this process that would sort of need some kind of working to become production scale. But we collected the soil samples before planting and mid-season. And at harvest time, we collected grain yield and protein. So Austin did half my job for me here and talked about what the weather conditions were like in Crookston this past summer. And this slide actually shows what the weather was like, the soil moisture was like for Lamberton in the past 5 years. So what you can see is there's kind of a smoother line in the middle. That is the historic average soil moisture in Lamberton. But where you can see those two lines kind of bottom out at the middle of the year. That's 2021 and 2022. So in Lamberton in 2021, they got a little bit more rain late, because as you all remember, up here, we were just dry all throughout the season. In Lamberton, they got a little bit more water late than we did. But in 2022, again, both northern and southern sites ran out of moisture late in the growing season. So when we're looking at soil nitrogen, and as we look at these graphs, just the lighter color is the not inoculated and the darker color is inoculated. If there's a star, that shows where there's a significant difference. So these graphs are all going to be kind of following that format, but I'll walk you through it. And in the after corn and after soybeans, we did see a response of that inoculum at the highest nitrogen rate. But we saw opposite effects. In one, the inoculated bacteria, the inoculated seed did a lot better. In the other, it actually did worse. So showing kind of inconsistent results of what this bacteria is actually providing to the soil. And in Crookston, kind of that's the same information. We again saw sort of nothing in either rotation, except at the 60-pound rate, the not inoculated did better. What I think this is probably just some variability that's showing up. This is why we do these trials for multiple years. We're not really seeing a consistent pattern. So even though we're seeing a statistically significant response, because it's not following a pattern, I don't really think this is overly meaningful, and might be something we need to dig into a little bit more. As far as total grain yield, we do have that the inoculated bacteria was providing about the same total grain protein as our non-inoculated. So not seeing a really big difference in that grain protein and the ability for the plant to fix nitrogen from the soil. In Crookston, those samples are currently being processed, but I wouldn't necessarily expect the results to be any different. Oh, now it's green. Okay, well, now for what everyone is interested in is really this grain yield slide. This is in 2021, and in 2021 we actually did not see a response except for where we applied no nitrogen, which I think this does provide some level of a proof of concept, right? So we can tell that this bacteria is fixing some nitrogen and performing somewhat as described, but we're really not seeing that it's able to supply nitrogen above and beyond what the plant can just fix on its own across those different rates. And we actually did see the same thing for wheat after soybean in Crookston in 2021. Again, that zero, when we applied no nitrogen, we did see that the inoculated seed had slightly better yield. But, again, that's kind of not necessarily a very realistic scenario. 2022 was a bit of a different story. We actually saw no significant differences at all in in our grain yields, either wheat after corn or wheat after soybean. The other thing I want you to think about a little bit here and keep in mind is that we actually didn't even see a response to nitrogen application rate in 2022. If you're looking at these yields, there's no significant difference whether we applied no nitrogen or whether we applied 120 pounds of nitrogen. And so this is really showing, our economic optimum rate of nitrogen in 2022 was 0. And that actually ties back into what we were talking about before, that rain limitation that we saw. We really were short on soil moisture in that grain filling stage, and so we actually didn't even get a response to nitrogen in this year. So it's actually really hard to evaluate how this particular bacteria performed when the plant is not responding to nitrogen in any sort of measurable way. So just to summarize again, we did see, again, that 15% response at 0 pounds of nitrogen per acre. And we did see slightly higher nitrate levels in some places, but it wasn't really consistent throughout either one. And 2022, we were so short on the soil moisture that we really saw no significant differences to any of our treatments. And we're not seeing the trend that we were hoping to. And again, this lack of the response, we do think could be because of the weather conditions. I think it's really tough because we can't make a final determination on whether this plant growth promoting bacteria is beneficial or not because we were so dry. So we are hoping to potentially continue this trial for another year and maybe, or maybe not, right? Get enough moisture for the next year. And with that, I just want to thank the wheat growers for their support these past couple of years, and I will take any questions. Yes.
So I assume that the bacteria that you're using is not commercially available?
Yeah, that's correct. It is not a commercially available. It's not.
Okay, so why not trial one of the products that is commercially available?
Yeah, so that's actually is a really good question. And so we did have a unfortunate situation that came up last spring where we were in contract to try a different bacteria, and we would sort of be able to compare the two results. The company actually sent us the wrong treatments, so we did not have an opportunity to put it in the ground.
I have a question. I actually have two questions. One of them was, I'm wondering if this bacteria survives the winter in the soil, or do you have to inoculate every year? And the other one was, does this form any sort of symbiosis with the plant, or is it just an asymbiotic nitrogen fixer? Is the benefit purely coming from it fixing nitrogen, or is there some kind of interaction with the plant other than that?
Yeah, and I don't actually know the answer to those questions. We're not testing to see if this bacteria lasts the winter. I think we're assuming that it won't. So we are re-inoculating every year. And I think the idea is that it does not form the symbiotic relationship, that it is sort of just this nitrogen fixer. But I don't know enough about the microbiology of the system to fully answer your question.
Okay, I had a question about the environment that you're putting the inoculant in. If a different tillage system or a regenerative system versus a conventional system would have an effect on survivability of the bacteria.
Yeah, I think that's a good point. We are planting this conventionally, a conventionally tilled plots. So there is absolutely some disruption that happens with the soil profile. I don't know if we haven't looked at it in different tillage systems, or if it's inoculated in a cover crop system, if that would be better or worse. But I think that would be something really interesting to look into. The question was if we'd done any work with Pivot Bio. I have not. I know that Dan Kaiser, who's in the Twin Cities, he has done quite a bit of work with Pivot Bio, and I think was finding maybe not real consistent results with that product either.
To add a comment on to that, to the Pivot Bio comment, we did get some requests, and we are looking into working with or testing Pivot Bio on wheat with the On-Farm Research Network. So we might not be doing small plot stuff, but we're going to try and do some stuff with it in the On-Farm Network.
Yeah, that'll be really interesting to see. Yeah, I think Dave Franzen may have done some work on Pivot Bio too, so you might look over in the North Dakota side.
And he refused to do work on Pivot Bio because they wanted to sign a non-disclosure agreement.
Okay, gotcha. So he's worked with other products, but not Pivot Bio. Okay, I think Joachim has a comment.
Just enough coffee that I can add maybe a little bit. Most of this work, when we start asking, the first thing is a non-disclosure. So there's a fair number of players right now in this field, but as land-grant university, if we want to start doing work on it, in many cases, there is a non-disclosure. And that's their prerogative of each of those purveyors. It makes it hard for apples-to-apples comparisons. And that's unfortunate, I think, for you as a consumer of these products. You'll see very scattered data. And if we get the data, we get data back to them. And nobody cherry picks their own data, right? Okay.
Yeah, and I guess with the On-Farm Network, we're just talking. If we're not able to share the data, we won't be working with them either.
Any correlation to plant health and using any of these bacteria?
Yeah, not that we have measured, I guess is probably we really just looked at the kind of production, the nitrogen impacts.
I think we got one more question down at the... Glad to see this is generating a lot of conversation, a lot of questions.
Yeah, I'm reading your research paper in the book here, and my question is the residual nitrogen left in the soil. And before you started the project, I'm trying to find, I don't see any numbers there on what was in the soil to begin with, and then what was in the soil when you were done.
Yeah, and that's a really good question. And my my co-PI on this project, Paolo, he worked up this data. So I actually don't have those numbers for you, but I will say that we probably had, I think he has said before that there wasn't very much residual left the first year. But just anecdotally speaking, especially wheat following corn in 2022, I mean, since we had the drought, we probably had residual nitrates left in the soil because we would have applied at a yield goal rate that wouldn't have been met with the drought of 2021. So I think that's a really good point, and that's something that we definitely do need to look at for this data set, because I suspect there probably was some residual there, but I don't have the numbers run to fully answer that. Yeah, because actually, if you saw, the wheat after corn did way better than the wheat after soybeans, if you noticed that when I was showing the yields. So that's a clue that we probably had more residual left in that system.
Lindsay, you touched on this a little bit already with sort of the microbial dynamics in the soil as well. So is anyone from the team looking at some of those dynamics? And I'm just thinking, for example, in terms of, it's not like you're putting a bacteria in an inert medium. You know, you have a lot of bacteria there already that the new ones will need to compete with. So is someone from the team looking at sort of how well that bacteria that you inoculate with, how they actually survive in the environment, both sort of in a very short term, but also throughout the growing season?
Yeah, and at this stage, we haven't been looking at that too closely. I know we did collect some soil samples for Satoshi Ishii during the growing season. So and he does have a student working on that right now. So I'm not sure. He was looking at what bacteria were showing up midway through the growing season. I'm not sure what the results of that were, but he would be the one to be kind of looking into that. Yeah.
I have one question. Are you using the same plot? It's kind of like soybeans. When we first started soybeans, we couldn't get them to really nodulate very well till the second time around. Are we doing that here? Do you understand what I'm kind of getting at?
Yeah, I do see and since this has only been going for 2 years, we did have 2 different locations for 2021 and 2022. So yeah, just. Well, I guess that's something that Paula and I need to talk about because we actually haven't decided that yet, but that would be a consideration. Yeah, it makes sense. And for anyone that maybe didn't hear, Scott was saying that it takes a while for that to potentially keep going. Oh, yeah. We have some results from Satoshi that Peyton had in her email. Peyton works for me. Peyton's my technician, so she's been really working a lot on this project and helping collect all the samples and making sure all the data gets run, and really helped a lot putting this presentation together too. So.
Do I push it? Okay, no, I can just talk. Okay, so there were 19 bacterial strains that were isolated, and none of them were identified as Azospirillum. However, there was Rhizobium and Xenotrophoman strains, which are known nitrogen-fixing rhizobacteria. So there were some nitrogen-fixing bacteria present, but not necessarily the one that we originally inoculated.
Was there any grain protein data collected in addition to the yield data in the plots?
Yeah, we collected yes. Okay, it's in process. So we collected it. We have not processed it yet.